Hello all, welcome to Geography with Sukumar. So today in this video I will explain the theory of plate tectonics. So what is the theory of plate tectonics? It is a scientific theory that explains how the Earth's outermost shell, that is lithosphere, is divided into different rigid plates and starts interacting with one another and simultaneously moving on the layer below it, that is called as the asthenosphere. So it is explaining about the tectonic activity of the various plates present on the earth's surface. So before coming to plate tectonics theory, there are various theories that have led to the development of the plate tectonic theory. So the first one is the continental drift theory, which is proposed by Alfred Wegener. So the main idea behind this continental drift theory is the continents are not static and they are dynamic in nature. That means not static, they don't stay at one place and they move. So according to continental drift theory, initially there was a huge continent called as the Pangaea, which later divided into Laurasia and Gondwana, and over the time those continents also divided into present 7 continents which are present on the earth. That is the main idea behind the continental drift theory. But the main issue with this theory is that it didn't provide the valid proof behind the movement of the continents. So scientists present at that time, they didn't accept the theory. The continents are drifting, continents are moving, okay, but the proof is lacking. So that proof is given by the convection current theory, which is proposed by Arthur Holmes. So what is the proof given by the convection current theory for the movement of continents? The main idea is heat which is present in the mantle region causing the convection currents, right? These convection currents are moving the crust above, okay, the crust plus the uppermost mantle which we are calling as lithosphere is divided into different plates, right? So these plates are moving because of the convection currents. So what is this convection current? Because of the continuous heat coming from the core region, the rocks in the mantle region will become melt or become semi-solid in nature, and because of the heat they will start expanding and they will start moving towards the crustal region, and they move up to the upper mantle region, they become cold and they will start moving away from the region, and they will become heavy and starts moving away from the region, and again they will come to the lower region. So this is a continuous flow, and this is what we are calling as the convection currents. And because of these convection currents, the layer which is present above the mantle, that is the lithosphere, which got divided into different plates, is moving, right? And the next coming theory is the seafloor spreading theory, which actually provided the place where this convection current is happening. So that is proposed by the Harry Hess. He said that oceanic crust forms at the mid-oceanic ridges. That means where the plates that are formed due to the division of lithosphere, where the divergence of these plates are happening in the mid-oceanic ridges, the oceanic crust is forming, the new oceanic crust is forming at those ridges and the plates are sinking at the trench region. This is the trench region, okay. So suppose if we have taken this as the mid-oceanic ridge of the Atlantic Ocean, okay, Atlantic Ocean. What's happening here? This is one plate and this is another plate, and this plate is moving toward this side and this plate is moving that side, okay. What is happening here? Divergence of plates is happening here, and the magma from inside the mantle is coming outside, and when the magma coming outside from the mantle region and when it is coming up to the crustal region, it immediately getting solidified and the new crust is forming here. and because of new crust is forming here and the plate is moving away like this, the plate is getting subducted under the another continental plate here, continental plate, right? So this plate is moving in this manner and getting subducted here. So the old crust is getting subducted here and the new crust is forming here. So that's what the seafloor spreading theory has said. So all these theories led to the idea of plate tectonics, that continents are not static and they are dynamic in nature. And the proof was given or evolved from the various theories like convection currents theory and the seafloor spreading theory. Okay, now we will speak about the plate tectonics theory, that is the modern theory which was proposed by the Mackenzie and Parker in 1967 and Morgan in 1968. So according to this theory, the lithosphere, which is the crust plus the uppermost mantle, is divided into different plates. As we can see here, these are the plates, different plates, African plate, North American plate, and these plates are not static and they will move, right? That's what the plate tectonic theory is stating. Those plates and the interaction between those plates can be divergent in nature or the convergent in nature. So when two plates are coming towards each other, that we are called as convergent, and when two plates go away from each other, that process we call it as the divergent in nature. Okay, and now we will see the different kind of plates. There are major plates and minor plates as well. Pacific plate, where we can find the Pacific plate, this is the Pacific plate. Eurasian plate is this one, and next Australian plate. These are some of the major plates, and some minor plates are also there. We can call them as here Coca plate, Cocos plate, Nazca plate, this one here, and the Arabian plate, this one Arabian plate, etc. So like this there are so many plates. And what is the composition of the plates? The plates can be divided into continent only plates or the oceanic plates or the mixed plates. What is this continent only plates? Continental plates. So the plates can be actually divided into continental plates or the oceanic plates. Continental plates means we can see here, right? There is no oceans are present on it, that is the continental plate, and the oceanic plates where the crust is having the oceans on it, that is the oceanic crust. So there is also a difference between continental crust and the oceanic crusts as well. The continental crusts have more width in nature and the oceanic crusts have very less width, right? Like that the plates composition has been different as well. So continental crust will be made up of silica and aluminum majorly, and oceanic crust are majorly made of silica and magnesium. So there is the composition difference also, right? When we see the structure of the plates can be, as we have already discussed, oceanic plates and the continental plates. The thickness varies. The oceanic plates have around 5 to 100 kilometers thin, and the continental plates are up to 200 kilometers thick. Okay, and they are oceanic plates, as we have just discussed, it is made up of silica and magnesium, and the continental plates are made up of silica and aluminum. And oceanic plates, which are made up of granitic rocks, because of the granite they are more denser in nature, and because of the density they will get subducted under the continental plates. Continental plates are less dense because they are made up of the basaltic rocks, which are less denser in nature than the granite. That's why the oceanic plates subduct under the continental crust. So why these plates move? According to plate tectonics theory, so why these plates are moving? Because of the mantle convection currents, like the conveyor belts, what we have discussed in the convection currents theory also same applies here. So the mantle convection currents are there. Because of these conveyor belts, the plates above the mantle region are actually getting pushed, Okay, the movement is because of the Montel convection currents only. So because of the heat coming from the inner core, the rocks which are getting melted and becoming semi solid and starts moving upward. Once they move upward, they gets cold and again they will sink, because once they get cold they become heavy and they start sinking, and once they get sink again because of the heating, right, again because of the heating they melt and they will start again to rise. That is what forming the convection current here. It's like a conveyor belt, and when they are moving like this, these currents, they will start moving the different plates present above them also, on which actually the continents are present or the oceans are present. Okay, and the speed at which the movement of the plates takes place, the slowest is the Arctic ridge and the fastest plate is the East Pacific rise. The slowest one is almost less than the 2.5 centimeter per year. The movement of the Arctic ridge is less than the 2.5 centimeter per year, but the fastest is the East Pacific rise, that has about more than 50 centimeters per year movement. Okay, the plate movement, still we have discussed about the plates, right? So how is this and how are they moving? So now we can see the plate movements. Suppose if two plates are traveling in the opposite direction, then we can call it as the divergent plates or the divergent plate boundary. The plates move apart, and because of the movement in the opposite direction, magma comes out from the mantle region above towards the crustal region, and they starts forming actually the mid-oceanic ridges. Okay, and various mountains as well, various volcanoes as well. That's what we are calling as the divergent plate boundaries. Next one, when one plate is subducting, or when two plates are coming towards each other and one plate getting subducted under the other, we call them as the convergent plates. Because of the convergent plates, when these plates collide, subductions happens or the folding happens, and because of those subductions the mountains are formed. For example, Himalayas are formed due to the convergence of the Himalayan plate and the Eurasian plate. Okay, and next we can see about the transform plate boundaries. When plates slide past each other, no crust is destroyed or created, right? So they will just pass each other by sliding. For example, we can say the San Andreas fault. Evidence of the plate tectonics. So what is the evidence provided by the plate tectonic theory here? The first one is the paleomagnetism. So what is paleomagnetism? Paleomagnetism is the study of the magnetic material of the rocks. So when the magma comes out up to the crust, and when the magma getting solidified to rocks, the minerals present on that magma will align in such a way that representing the magnetic polar regions location. So the minerals in that specific rocks are aligned in such a way providing the location of the polar regions or magnetic poles present at that time. So rocks formed at that time will give us the location of the poles in a different location than we are seeing the rocks which are getting generated right now. So when we see the magnetic material alignment in the new rocks that have formed recently because of the magma, they are showing the different location now. So that means the magnetic stripes in those rocks reveals that the location of poles are changing, magnetic poles are changing. That means the continents are moving. And the age of rocks also, when we see young rocks on the ocean floor, we can see them at the mid-oceanic ridges, and we can see the old rocks on the place where the subduction is happening, like in the mid-oceanic ridges in the Atlantic Ocean. So in this Atlantic Ocean itself only we can see young rocks and the old rocks. The young rocks are appearing near the mid oceanic ridges, and the old rocks are happening to appear on the subduction zones. And when we see the trenches at the subduction zone, we can observe the gravitational changes or gravitational anomalies. So, and the other one is the earthquakes and the volcanoes are also founding along the, we can found them along the boundaries of the plates where the plate tectonics is happening. These are all the proofs that are given by the plate tectonic theory. So, thank you.